Hello, and welcome to this Richardson, Skyworks, and Sequans webinar. With us today is Shri Sridharan. Shri is a Senior Product Marketing Manager at Skyworks. Joining him today is Jeremy Gusto. Jeremy is a Senior Project Marketing Director at Sequans.
Good day, everyone. I'm Shri Sridharan from Skyworks Solutions. I'm very excited to discuss with you how cellular system and package connectivity solutions are enabling Massive IoT product launches. Skyworks and Sequans have partnered together to develop such a SiP solution, the 66430-11. The presentation will cover some of the basics of licensed LPWAN technologies, LTM and NB-IoT, and review some of the key challenges in adding cellular connectivity to an end device. I will be joined by Jeremy Gusto of Sequans to outline the cellular certification process and some of the key takeaways as 3GPP evolves its standards to 5G. Most importantly, you will hear from two real-world IoT device makers on their journeys in adding cellular connectivity to their end products. Finally, we will wrap up with some Q&A. So when you look around, there are a lot of different wireless communications technologies available, all offering trade-offs between data rate, range, and power consumption. They can be grouped by personal area networks, PAN, local area networks, LAN, and wide area networks, WAN. A subcategory of WAN is licensed low-power WAN, or LPWAN, shown in the yellow box on the bottom right. That means secure, operator-managed cellular connectivity in licensed spectrum and has two technologies, LTM and NB-IoT. At a high level, these two technologies are referred to under the moniker Massive IoT. What that does is it provides a classification under the 5G triangle for low power, low data rate connectivity for a huge number of devices, up to 1 million devices per square kilometer. LTM is utilized for latency-sensitive, low data rate mobile wireless applications such as a wearable device or asset tracker. NB-IoT, on the other hand, is applicable for latency-tolerant, extremely low data rate fixed wireless applications. You can think of a smart meter or piece of factory equipment as examples. Most of the commercialization today on LTM is focused on Cat M1, and for NB-IoT, it's Cat NB1 and moving to Cat NB2. So who can benefit from these technologies? There's a wide spectrum of use cases that are adopting LTM or NB-IoT, from metering, asset tracking to wearables, medical, and so on and so forth. There are literally hundreds of applications, some we likely don't even know about today, that can benefit from these technologies. What is interesting is, even within some of these applications, both LTM and NB-IoT can be utilized. For example, a wearable device, based on how it is used or defined, can use either or both licensed LPWAN technologies. Familiar map to some of you who have been developing cellular IoT solutions, the GSMA has been tracking commercial LTM and NB-IoT network launches, and as of May 2021, the number has exceeded 150. It's kind of an east versus west dichotomy, with NB-IoT being deployed primarily in Asia, while both LTM and NB-IoT are being deployed in the Americas and Europe. Let's talk about some of the challenges when adding cellular. So one of the key reasons why we haven't seen the uptake of cellular IoT like we have of Bluetooth, Wi-Fi, or other technologies is that it is quite hard to add cellular connectivity. The slide shows just some of the key considerations that must be flushed out, including desired band coverage, required certifications, coexistence with other radios, level of location accuracy, and so on. Then there are software, security, and legal considerations that must be addressed in order to successfully launch a cellular IoT product. Let's take a look at some of the challenges we face at Skyworks. As a cellular IoT solutions provider, Skyworks has come to appreciate some of the many challenges in developing the hardware. There are system-level challenges like managing cellular harmonic interference to GPS L1 or cellular transmit noise in the GNSS receive bands. Depending on the band coverage that needs to be supported, coexistence with 2.4 GHz Bluetooth Wi-Fi can also become a key issue. While this can be managed with improved antenna decoupling or enhanced harmonic filtering, since LTM and NB-IoT operate in half-duplex mode, there are also schemes that can be used to blank the Wi-Fi signal when cellular is transmitting. Sometimes, even when you add an enhancement like conformal shielding to reduce electromagnetic interference, it can degrade something else like the EVM. The placement and routing of the PCB are extremely critical, and many inexperienced product designs fail due to poor PCB layouts that do not adequately decouple digital signals from reaching the RF and clock signals. For IoT devices adding cellular for the first time, this can lead to painful product iterations, especially when the industrial design and aesthetics take precedence over the electrical design. Finally, not to be understated, the RF calibration and test can make or break the product design. RF calibration is required to optimize performance, but based on how it is implemented, it can impact overall product cost. There are also many tests that need to be run to validate the product performance, increasing the time to market. So just given the challenges in developing the hardware, it is imperative that companies forge partnerships to combine strengths and leverage their respective competencies, which can vary from expertise on the cellular modem, PA design, software, certification, or other aspects. As you can see from the Beecham Research graphic, the world of IoT is quite daunting. To address the need for turnkey cellular IoT solutions, Skyworks, an established leader in RF front-end solutions, came together with Sequans, a pioneer in cellular IoT modem platforms, to develop a multi-year collaborative partnership. Both companies were early to recognize the benefits that licensed LPWAN technologies could bring to the IoT market and decided to join forces to really move cellular IoT forward. The solution: a system and package for Massive IoT. The result of this partnership is the world's smallest Massive IoT solution, the Sky 66430-11. The Sky 66430-11 is a turnkey connectivity solution supporting 18 bands globally, is pre-certified with major network operators, can support both LTM and NB-IoT deployments, and has the lowest power consumption of all commercially available cellular IoT devices. Overall, the Sky 66430-11 integrates baseband, transceiver memory, and the RF front end, along with more than 90 passives, all into a single package. Now, this product is in volume production and is being used in IoT devices today. So even if you have a great product that utilizes cellular connectivity, unfortunately, that's simply not enough. For one, you must ensure your product is not infringing on someone else's intellectual property. By definition, any standards-based technology such as LTE-M has essential patents, so the connectivity solution that you choose must offer SiP indemnification, as not all solutions are created equal. The great news is that Sequans is able to offer this coverage with the Monarch SiP. In addition, procurement of components has taken on an increased sense of significance as evidenced through the experience of the pandemic. Shortages and long lead times have left many great products unable to launch or grow. Then there's data plans for IoT devices and managing multiple devices over a global network. It can get quite overwhelming. Our distributor, Richardson RFPD, does a great job helping our customers navigate through all the options. One of the core competencies we brought to the table was integrating multiple die into a single overmolded package. By doing so, we were able to reduce the X, Y, and Z dimensions to achieve an extremely small form factor SiP. In addition, we coat the package with a conformal shielding and apply selective shielding techniques to improve RF performance. And because the package is free of silver, it is an excellent solution for applications such as gas meters that contain sulfur. The unique package also enables flexible, quote, SiP on board designs. Jeremy from Sequans will expand on this further, but the SiP has been pre-certified as a traditional module with major network operators. One of the key features that 3GPP introduced with LTE-M and NB-IoT was the ability for an IoT device to extend battery life. With EDRX, or extended discontinuous reception, the device is not continuously listening to pages from the network. In fact, the device and network can negotiate sleep times between paging cycles, with the trade-off being reachability with increased latency. The slide shows the Sky66430-11 power consumption versus the competition for various EDRX cycles. As you extend the sleep cycles and increase the time that the device is dormant, the Sky66430-11 increasingly outperforms the competition. Now, if you extend that even further to a, quote, deep sleep power savings mode, or PSM, the Monarch SiP can achieve a best-in-class power consumption of 1 microamp, which is a significant benefit for battery-powered IoT devices. We are all familiar with GPS, Bluetooth, and Wi-Fi that's in our phones and other connected devices. But the problem is that they are power hungry. GPS specifically doesn't even work indoors, and with Wi-Fi and Bluetooth, you can't really use them outdoors. So what we have done on the 66430-11 is integrate a unique cellular positioning technology, 100% software-based, called Positioning over LTE, or PoLTE, that works anywhere, indoor or outdoor. Instead of performing location computing at the device edge, it happens in the cloud, reducing the overhead at the device level and making the data available for customers through a secure API. If, for example, they wanted to find out where their assets are and how they are managed. This again is a valuable benefit that can reduce overall device power consumption. Skyworks and Sequans have developed a simple, easy-to-use evaluation platform for the SiP. All you need is a laptop with USB connectivity. The evaluation kit comes with a 3-month prepaid data plan and can be easily ordered from Skyworks and its channel partners. In addition, the Sky66430 is supported with a complete set of customer support documents, including the full datasheet, evaluation kit user's manual, reference design documents, and ET commands manual. Documents can be easily accessed through the Sequans Support Cloud Portal. Well, I hope that was informative. That's all I have for today. Thanks for listening. Now, over to Daniel Dora of Pebblebee. Take it away, Daniel.
Thanks, Sri. I'd like to introduce Pebblebee and our experience in adding cellular to our products. At Pebblebee, we have a multitude of products that aim to solve a big problem with everyday life, which is losing your belongings. Our products range from Bluetooth only to cellular, and we have growth plans for satellite and more in the future. Our latest product is the Found LTE, which is a real-time location tracker for valuables and pets with a long battery life on a single charge. Our unique proposition is the small-sized tracker that fits on almost any household pet and includes a buzzer for locating your belongings remotely. An example of this is when I lost track of my dog Thor in the neighborhood, I was able to see them on a map with the Pebblebee app. And however, that area was very dense. It was a dense forest. And the only way I was able to locate Thor shortly thereafter was by buzzing the found LTE device remotely with my app. So that is a very unique feature. And the other unique benefit of the found is that it provides indoor location regardless of GPS satellite signal quality. We do this by incorporating advanced algorithms with positioning over LTE. This means that regardless of the environment, the found will still be able to provide your belongings location. Given that our number one goal is providing peace of mind, we needed affirmation that our product is safe and dependable. And all aspects of the found, ranging from hardware to cloud, app solutions, they all needed to integrate harmoniously so that we can deliver a dependable solution. The most critical piece of the hardware is the Sequans LTE modem and system in package by Skyworks. We needed a low power solution that is very small and would fit our needs for a pet tracker. But most importantly, we needed a dependable solution that, regardless of the environmental limitations, would deliver reliable results and ultimately a good user experience to our customers. So we interviewed a dozen different providers in this space, traveled the world in search for the perfect solution. We interviewed dozens of companies on their experiences and developed several prototypes with different solutions. The end result, however, is the best-in-class solution, and that is the Monarch SiP Sky 66430. We are very happy with the solution, both from a technical and support perspective. Now, adding cellular to a product line is extremely difficult. It's a difficult task because there are so many dependencies that play a very critical role to ensure a very good user experience. Partnering with strong brands such as Sequans and Skyworks has made this process a much more streamlined process, although it's still a very difficult task. You know, I wish I had a magic wand I could just wave and create this type of infrastructure and foundation needed for such a colossal task. Although we have a very nimble and efficient team of over 7 years experience in this market, especially Bluetooth trackers, and perhaps a little over 4 years experience in cellular, it was still very difficult to build the found LTE. We had to re-architect and redevelop the found LTE twice, given its many challenges, such as a very small space that we needed to develop for attaching to pets, for example, and also that it has so many capabilities. So we had to redesign the software and hardware multiple times to ensure a very good user experience. And we ran into many challenges with regards to making the device very small, for example, antenna design, and making it last very long. So maintaining this robust and dependable product was a very difficult task because of its challenges, physical challenges. Customers expect a lot from the found LTE, and we need to ensure a very reliable experience. So we had to perform better and differentiate ourselves from existing competitors. And this takes considerable financial investment and a devoted team to delivering ultimately peace of mind to our customers. You know, and building a cellular product requires a robust cellular network, obviously, right? And of course, software tools that enable us to efficiently manage subscriptions through the cloud. We use AWS, for example, for our databases and tools, and we have our own tools. We've developed our own custom services to provide a full stack of services to our customers, including subscription services. When it goes from cloud to apps, including iOS and Android, and marketing and payment solutions, all have to be updated to support these new subscription services. The hardware also must be very power efficient. That was a very difficult task. Very minute little tasks that caused so much power drain on the device. We had to really perfect it and try to minimize power consumption in every other way, in every corner, in every part of the product in of itself, including handing off, for example, location services to Bluetooth devices such as your phone, whenever it's possible, whenever it's within range, and minimizing cellular and GPS services when the device isn't moving as much, right? You don't need to continuously update if it's not moving as much. So building a world-class service with good quality hardware is a monumental task, but with the Pebblebee team and a strong ecosystem partnerships we've established over the years, I think we've anchored a solid foundation which allows us to execute a plan for success. So to summarize, the found LTE in general, we needed the cellular modem to have the smallest form factor, be very power efficient, include indoor location services, and most importantly, have the best in class technical support, which helped us in so many ways. The Monarch SiP was the smallest solution available on the market, which allowed us to minimize the found size, the found LTE size, so that it can be attached to almost anything valuable, right? Just even your keys. But don't let her size fool you, because it packs a tremendous amount of punch, and we're using every bit of its capabilities to maximize the end value for our customers. So the Monarch SiP has, again, best-in-class power savings, especially when used in power savings mode or PSM. And when you don't need or want to continuously transmit location or information of any kind, you can enable extended discontinuous reception, which is EDRX mode, so that you can activate location tracking remotely when the device is in listen mode, which consumes a lot less power. You know, when EDRX is available in the network in that location, you're using the found LTE. This can be a very huge power saver. And last but not least, the Monarch SiP is integrated with POLT, allowing you to locate your belongings even when GPS is not available, such as in a parking garage or in a dense urban area or very heavily treed forest where GPS is not available. You can still use POLT. This gives the Monarch a big advantage to our competitors, you know. And so as we look to scale our business, Skyworks has been very supportive on our supply chain needs and continues to look for ways to help us excel and navigate our manufacturing challenges. So for more information about the found LTE and other products from Pebblebee, please check out pebblebee.com. Now I'm going to hand this off over to Jeremy Gusteau at Sequans. Thank you very much.
Hello there, my name is Jeremy and I'm doing product marketing for Sequans Communications. Thanks very much indeed, Daniel, for your presentation on one of your Pebblebee cellular products. We're really glad to have had the opportunity to work together on that product and its siblings. They all bring a great user experience, integration, battery life, and services. As Sri mentioned, Skyworks and Sequans are partners on the Monarch SiP product, and RFPD distributes it. When Skyworks brings their market knowledge and their technical expertise to manufacture the SiP, which is the thinnest in the industry, and benefits from a silver-free technology that allows usage in corrosive environment like that experienced with gas and water meters, at Sequans we bring our Monarch baseband and RF technology together with our 3GPP standard knowledge. Certification is definitely one part of what we bring to the balance, and we're glad to share this experience to facilitate our customers' adoption of cellular technology and overcome what could be otherwise considered a decisive challenge in designing a cellular-based product. First of all, Monarch is certified worldwide in LTE and Urban IoT, very much unlike any of its competitors to the same extent. Monarch and Monarch SiP have been out there for more than 4 years now, and our software maturity and certification expertise are benefiting our customers. First, from a regulatory aspect, our solution has been certified in the US with the FCC, in Canada with the IC, Australia with ACMA, Europe with RED, and Japan with JET and TELEC. Also, our software maturity is guaranteed by a 3GPP compliance, which is assessed through dedicated certifications with the GCF and the PTCRB, which many operators rely on for compliance to 3GPP standard. Finally, we've been certified with many operators, which you can refer to on this slide. To name a few, you will see our solution certified in North America with T-Mobile, AT&T, Verizon, Dish, TELUS. In Australia with Telstra, in Europe with T-Mobile and Orange, LGU Plus in South Korea, Docomo, SoftBank, and KDDI in Japan. We're also expanding, or looking at expanding, This list with many different operators like Telefonica, Telenor, O2, Vodafone in Europe, Bell in Canada, and so on. Now, what does this mean for our customers that will end up choosing Monarch SiP in their end product? Sri mentioned it earlier on. Designing a cellular product is a journey that includes some challenges. One of those challenges is the certification aspect. Working with us and choosing Monarch SiP will help you through that journey. You will hear that all cellular modules are certified with major carriers. Some will have a few, others 5, others 10. Total number shows some experience in the certification process and the actual maturity of the solution. But here, we're also taking you to the next level. When you work with Sequans, we're explaining what is left for you to do, and we'll support you through all the steps with regulatory 3GPP compliance as well as with MNO or MVNO approval. We have all labs and carrier contacts to support you all the way until your product type approval. For example, with the regulatory side, you already know that Monarch SiP has been accepted by major regulatory bodies. On your end, regulatory certification is a must-have for the end product. It will be based on module certification, and some tests that will be performed include, for example, RF emissions versus LTE module using your end product antenna. Now, for the 3GPP compliance, some carriers may ask you to get this done. It's not as systematic as the regulatory part, but you may need to be prepared. Basically, what would be assessed is, for example, what relates to your interface with the cellular module, like the audio interface, RF spurious emissions, SIM usage. On the carrier aspect, if you choose to work with an MNO and their data plan, you would need to apply for their dedicated product certification. This product certification would likely include antenna TIS and TRP, SIM activation. Sometimes you may be asked to perform some product functionality testing and some firmware over-the-air update as part of this certification. And usually on top of that, 3GPP compliance would be mandated. Working with an MVNO could be somehow different. Usually an MVNO would ask you for 3GPP compliance, but there wouldn't be any extra dedicated testing which would be asked for you. This is to be seen on a case by case. Working with us and with our FPD, you can ask us for help to select the right data plan for you and for your use case. Now, we've been looking at how using Monarch SiP can help you getting your product quickly through the certification hassle. More generally, you will see that using Monarch SiP brings you the same value as working with any module, but it brings you the hardware design flexibility that you would get with a chipset, and you are much more in control of your real estate through that very tiny package of the SiP, as you will hear right after from Andre with his Nebo product. But unlike any chipset, you will save a huge amount of time and money by working with Monarch SiP. You save on your development cycle as well as on the certification cycle. Both cumulated, we believe that you can save from $300K to $600K and somewhere between 4 to 6 months of time to market. And saving in the time to market is more money quicker in your pocket, so a much quicker return on investment. Besides, you can focus on your actual end device design and end-to-end integration with your cloud services, for which we have a dedicated set of AT commands, rather than on the hardware design and low-level software development. Once your product is developed and certified, you will also need to fully qualify it, and to bring it to mass production. Here you will see the value of working with Monarch SiP in terms of getting CapEx and OpEx savings, as well as in terms of the support you will get from Skyworks and Sequans teams. Unlike any chipset, and much like any module, our SiP is coming fully tested and calibrated, saving you the CapEx of the test equipment and the OpEx of the test time. What's left on your end is the end product testing with a final screening that will help you check that your basic connectivity works well and that your antenna and connection to the SIM card work properly, and you don't have to suffer from any quality issue. All in all, we evaluate your savings to about $30K in equipment and 1 minute of test time on the end device. And in terms of testing, time is money. Now, for the IoT to be truly massive, Two key elements were needed. One is low cost and the other one is low power. As such, a vast majority of products and applications can embed the cellular connectivity. Here we focus on low power. Some technologies like LoRa and Sigfox got a great success when they came out 6 to 7 years ago. And they both have these common attributes of low cost and low power. Although they can come as great alternative to cellular technologies in some specific use cases, they can rarely be implemented and deployed at large scale with an operator that can fully guarantee the quality of service to the same extent that what exists today with cellular technologies. Cellular connectivity such as LTE-M and Narrowband IoT came out at the right time and with the right technology to be truly cost competitive and very low power. At the right time, because the market was in search and in need of a cellular technology that can bring to the market billions of connected things. Besides, for better usage of the spectrum, operators need at some point to switch off their 2G and 3G network for a more optimized 4G and 5G connectivity. And with the right technology, because the half-duplex FDD operation combined with a single receive chain have been key to bringing the cost down and to bringing a rival to 2G and 3G in the arena. In terms of power optimizations, 3GPP came first with two features that did not exist with 2G and 3G, PSN and EDRX. You got a glimpse of the value of these features with SRI. And the standard guys did not stop there. After release 12 and release 13, they're coming at every release with new features that are continuously improving the power consumption. In release 14, the main additions were to increase the peak data rate. In LTE-M, the uplink data rate is tripled in uplink and almost doubled in downlink. And the rule of thumb has it that your power consumption will depend on your air time. The quicker you transmit or receive, the less you consume. Similarly, Narrowband IoT is introducing a new UE category called CAT-NB2 that allows multiplying the data rate in uplink by a factor of 2.5 and in downlink by a factor of 4. Yes, we're talking here about peak data rates in good radio conditions with no repetition, but still, the gain factor is here. Other features from release 14 and subsequent releases are continuously improving power consumption, like the release access indication, RAI, that allows the UE to indicate with a bit that it's done transmitting, hence saving some significant protocol exchange between the network and the device. Other such protocol savings include the wake-up signal or the early data transmission. The latter allows a swift uplink transmission during the attach phase, saving significant latency in the initial transmission. You might have noticed in Monarch SiP promotion and in previous slide that we're mentioning both 4G and 5G, and as a matter of fact, MMTC, Massive MTC, is the 5G evolution of 4G MTC with LTE-M and Narrowband IoT. It is fully operated on the legacy LTE spectrum using LTE radio, meaning we're not using here the 5G NR, the 5G new radio. It is also designed for high connection density of up to 1 million devices per square kilometer, which is 10 times the maximum amount possible with 4G infrastructure today. Monarch SiP complies to MMTC requirements by design. It's a 5G technology by design. As further illustrations of its low power capabilities, you can see some two typical figures when operating in low power mode. A typical daily power consumption when the device is transmitting a small amount of data, like a few kilobytes on the cloud once a day, is of 300 microamp hour. Whereas if you wish to keep some reachability with an EDRX cycle of about 5 minutes, transmitting the same amount of data will cost you, for that day, 800 microamp hour. In both cases, you will witness our industry-leading rock-bottom power consumption of 1 microamp. As discussed just before, if you engage with us, you will not only benefit from all great value of Monarch SiP, you will also work with two companies on the long term with the next generation of products like the Monarch 2 and its sibling module-like Monarch 2 SiP. Coming along will be an integrated application SDK, a secure enclave, which is unique on the market and enables the usage of integrated UICC, saving the cost of a discrete physical SIM card, while keeping a great coverage with a 23 dBm power class. All this and much more to come. I'm now handing over to Andre from Datrix. Andre will talk to you about NIBO, an unprecedented concentration of technology in a very tiny object that can prove so vital.
Jeremy, thank you for introduction. One more time, my name is Andre and I'm CEO and founder of Datrix. Today I'm going to talk about NIBO LTM, we call truly remote child well-being monitor. NIBO LTM is the successor of NIBO Bluetooth Wi-Fi, the device which was commercialized in September 2019. The biggest difference between these two is that NIBO LTM is fully autonomous and has a location tracking feature. What market we're trying to address and how big is the problem? Today, more than 60% of health and life-threatening cases happen when a child is awake, and more than 15 million children in the EU and US alone require their vitals to be constantly monitored. This is because of SVT, asthma, seizure, sleep apnea, reflux, autism, and other conditions. And all of this can be generalized under a single pain point as a necessity of a continuous monitoring solution. There are 6 criteria need to be met for the ideal continuous child monitoring solution, which are: first, monitoring, ability to monitor the main vital signs by third party; second, mobility, a small device size which is able to follow a child; third, placement on child's body which doesn't restrict their movement; fourth, stability, which is ability to measure vitals with high accuracy in spite of the movement; fifth, autonomy, when there is no need for a hub or bridge device in proximity to connect to the cloud; and 6, location tracking. 4 of these 6 is really bare minimum required, which NIBO Bluetooth Wi-Fi satisfies. However, only NIBO LTM is able to meet all these requirements. The biggest challenge for us was to keep the device miniature, taking into account that it's used for children from 0 to 8 years old. The size you see on the screen is the most optimal for child's comfort, especially during the active movement. LTM modem is the biggest component in NIBO, and the ability to fit it in would make this project impossible. So there was only one suitable solution, the smallest form factor Monarch SiP. Big bonus for us was its smooth integration with NIBO's STM32 MCU through Monarch AT commands pre-integrated with ST SDK. If you have any questions or just would like to talk, please email us to contact@datrix.com. Thank you.
All right, gentlemen, thank you so much for a great presentation. We are going to move into some live Q&A now. Reminder to our attendees, if you have a question for our presenters today, please enter it into your Q&A window and click submit. We will do our best to get through all the questions today. If we do not get to your question today, do not worry. We will reach out to you following today's webinar. So gentlemen, let's get into the Q&A. Our first question today: your product is interesting, but I'm not sure who to work with, Skyworks or Sequans.
Thanks, Katie. You have the flexibility to work with either Skyworks or Sequans. Both have a global sales and FAE presence. So you can work with either company to get started, and most likely you will actually interface with both through your product development. Skyworks can help with the RF, hardware design, and PCB aspects, while Sequans is the expert on the software and certification.
Okay, Shri, thank you so much for that answer. All right. For external components, if any, are required for the Sky 66430-11.
Yeah, I can take that one. So the goal with the SiP was to develop an extremely compact solution in all dimensions that offered a lot of flexibility to our customers. And as a result of that, we integrated almost all of the key functions required for a typical Massive IoT implementation. So the solution does require an external flash, PCXO crystal, and a few passives for the power management circuitry. But even with those external components, the total solution size is really hard to beat.
Okay, Sri, thank you so much for that answer. All right, we're going to go back to Jeremy's question. How long does it typically take to get a connected cellular IoT device to market?
Thanks, Katie. Can you hear me better now?
Yes, Jeremy, you sound great. Thank you.
Okay, brilliant. Sorry for that. So yeah, that's a complex question because that really depends on your internal capability and past experience integrating a cellular technology. Using Monarch SiP, you'd be looking at a hardware development of several weeks, depending on your hardware team experience on cellular designs. We will obviously support you through that process of schematic, layout, and initial bring up, as Sri just explained, making sure nothing is being missed and you're not spending your money on a bad design. But yeah, overall for that, hardware development part, you'll be looking at several weeks. For the software design, the effort will necessarily depend on the complexity of the hardware and also your past expertise. We have customers with different duration in that software development phase, spanning from 2 months up to 6 months for the development, stabilization of the overall solution, and obviously that would include some field testing. So overall, that could sound like a lot, but some of these activities can be done in parallel to the hardware design because you can start the software development using the evaluation board from day one so that you don't need to wait for your hardware to be ready. You can start developing your software. And so what we see from customers is that from the start of a project to the production readiness, we see duration ranging from 6 months to 12 months. This is kind of typical in the cellular industry, and we're trying to get this accelerated through our support, hardware and software-wise, between Skyworks and Sequans. And so yeah, we'll be helping you all the way, hardware design, integration of AT command on your MCU, qualification that includes field testing, certification, and the production. This is where you will get, you will see the value of our partnership together with Skyworks.
Okay, Jeremy, thank you so much. How the Pulte Cloud works in a private APN environment?
Sure, I can answer this one. Katie, thank you. This is Daniel from Pebblebee. Oh, pardon?
Yeah, go ahead, Daniel.
Okay, so our experience has been that we've done 2 different solutions. One that the chip itself, the device itself, would connect directly to Pulte Cloud in order to get a resolution, a lat-long resolution. Or you could have the device communicate directly with your private cloud, and then your private cloud would need to connect directly to Pulte Cloud to get a resolution. Pulte also does have a service called Core Res Beta, which will allow a cellular chip to create retrieve the information needed, and then you can use your API to connect to Pulte Cloud directly. So you would have, so you could have it send to your APN, and then your private cloud would just need to communicate directly with Pulte for a resolution. So it's possible, but I believe you still have to communicate with the Pulte Cloud to get a fine resolution.
Okay, great, Daniel. Thank you so much for that answer. Next question here, gentlemen. How are you handling security to make sure that transactions are secure end-to-end from device to cloud?
Yeah, I can answer this one. That's a good question again, because security is key in IoT devices. You've all read a lot of articles talking about security, and that really matters to us. So first of all, by essence, compared to some other non-cellular technologies, LTE transactions are secured. Then our protocol stack in the LTE solution that we offer to our customers embed a security layer with support of TLS 1.3 for TCP and DTLS 1.2 for UDP. With this, and with the support of FTP, HTTP, and MQTT protocols, which we fully embed in the Monarch SiP software offering, you can support cloud transactions in a secured way with FTPS, HTTPS, and QTTS. And we've also, in some cases, with a couple of customers, been working with an external ECC chip from Microchip, which can help you enhancing the security in terms of authentication as well as ciphering. And should you be interested in using an ECC, we've had this activity done already with Microchip, which we will be happy to reuse and to provide you with the basic brick of implementation to connect a Microchip ECC with a Monarch SiP. And that's something that would increase even further the security of your IoT device.
Okay, great. Thank you so much. Next question here. Is 5G NR supported?
Okay, I can take this one as well. 5G NR, so we talked about 5G and we're saying that Monarch SiP is a 5G device. It's a 5G device, but when it comes to massive MTC, 5G MMT, so 5G MMTC is actually running on the LTE spectrum, and it fully relies on LTE and narrowband IoT as underlying technology. So when we talk about 5G MMTC, there's no such a support of NR. NR today, the new radio, the new waveforms that have been designed for 5G are fully part of the enhanced massive broadband section of the 5G, meaning you use NR, sub-6 gigahertz or in millimeter waves for whatever relates to very high data rates or very low data rates, such as what you would get bit in the range of several hundred of kilobits per second for massive MTC, are still fully handled by LTE and narrowband IoT. So there's no need to support 5G NR to support 5G, but you can be 5G massive MTC compliant with LTE and narrowband IoT as long as you implement it with the features coming in release 14, 15, 16, which is what we're doing with Monarch SiP.
Okay, thank you so much for that answer. So gentlemen, the next one here. There are several Cat-M module solutions on the market today. How does yours compare?
Thanks, Kitty. I'll answer that one. Yeah, very well. From a size standpoint alone, I think we are second to none. The less than 1 millimeter height opens up a lot of flexibility on space-constrained product designs. Then there's the 1 microamp PSM rock bottom current, which is the lowest in the market. But most importantly, we have an extremely mature solution that is certified by major MNOs, and we are already shipping in volume. And Jeremy touched on this in his presentation as well. We have a roadmap to support the new features of Monarch 2 with the follow-on product. So, working with our mature solution gives you a nice transition to future designs using Monarch 2 as well.
Okay, great. Thank you so much for that answer. Another question here. Can we develop custom APP to run on the module itself?
Let me take this one, Shrey. Our basic offering is done in such a way that it's optimized in power consumption and can be used with any external MCU. We have a lot of customers already using standard MCU from Microchip, NXP, ST, Renesas, and they're just looking at adding connectivity with no willingness to develop their software. And this is really where our solution has been truly optimized, running with any external MCU, so that we minimize power consumption on the LTE subsystem itself. So besides our MCU partners that I just mentioned, have an SDK that is pre-integrated with Monarch with our own set of 80 commands, so that it gives an easy way of implementing with any MCU out there. Now, having said that, if you have any specific software need that would require implementing some light application with a Monarch SiP, you can reach out to us and we'll be happy to assist and see what can be done.
All right, great. Thank you so much for that answer. Next question, where is this SiP manufactured?
Yeah, I can answer that one, Katie. So the SiP is manufactured in North America, specifically by Skyworks at one of the largest assembly and test facilities in the world in Mexicali, Mexico. So Skyworks has extensive experience in manufacturing system and package type products, and the factory there has spent years perfecting the recipe of the 66430-11. So this is another key differentiator for the SiP. You're getting a proven module manufacturer that is integrating at the die level, not just buying package components and putting them together on a PCB.
Okay, great. Thank you so much for that answer. So another question here. How often do I need to update the firmware, and how easy is that to do?
Well, that's a fairly standard procedure that needs to be planned at product level. Any protocol can be used to manage the firmware update depending on the server that will be hosting the image. We have customers using an HTTPS server to host their new firmware, so which can be used for the application running on the MCU as well as for the module firmware. We also have other customers relying on the infrastructure, which is often by the operators, to update their firmware. We do offer an embedded lightweight M2M client that has been certified with major operators that offer this support of firmware over-the-air update using lightweight M2M. Generally speaking, we also advise for the application to be done in such a way that you do support a differential image so that you can do differential photo to minimize the impact on battery and on your data plan rather than updating the full image of your application. That's what we do on the module side, and we strongly advise it to be done as well on the application side, to get it streamlined whenever you need to do a firmware update. And then, based on the fact that we support all the needed protocols for HTTP, FTP, and others, and a lightweight M2M client, you can use this to update your firmware. You're also asking, about how often do I need to update the firmware? I believe that was the start of the question. We usually count on the fact that you might have to update once or twice the firmware during the product lifetime. When we try and do power consumption estimate for our customers, that's we usually what we recommend, that you need to account for a couple of firmware updates, because you never know what you might need to update in the future because of bugs, because of new features. And so, maybe twice would be a good answer to that question. How often do I need to do it? But that really depends on how much you want your product to evolve and how long you want it to last on the network.
Okay, thank you so much for that answer. So our last question today, gentlemen. If I want to use the SiP in my design, do I need any special PCB assembly tooling?
Thanks, Katie. I'll take that one. So special tooling is not required. Most manufacturing facilities that can assemble BGA packages already have the necessary tooling needed to pick and place the SiP from a reel and reflow it on the PCB. So we have developed also PCB design guidelines as part of the reference design documentation to ensure as seamless of an experience as possible for customers to add the SiP to their product.
All right, thank you so much for that last answer. I do want to say a huge thank you to all of our presenters today. So that's Sri and Jeremy, and then for Daniel for joining us for the Q&A. So gentlemen, thank you all very much for being here with us.
Thanks, everyone.
Thank you.
Thank you.